A volunteer firefighter stopped by our booth at a trade show and said, during an extrication demonstration, the cutter I was using froze in the middle of a cut. I held the valve wide open, as my instructor taught me to do, and it cut within seconds. My question is, why did it stop in the middle of a cut? The simple answer is hydraulic pressure. But for those who are new to hydraulic systems, situations like this are anything but simple. The AMKUS hydraulic system, like many rescue tool manufacturers, is an open circuit system. The pump in an open circuit system supplies continuous flow. As long as the control valve remains in the neutral position, the fluid bypasses it and flows back into the reservoir. However, when the control valve is engaged, meaning you move to the right or the left, the fluid is diverted into the tool. It's here that fluid enters the cylinder, where it immediately encounters resistance as it begins pushing the piston. Any form of resistance, whether it's pushing a piston or cutting a vehicle door hinge, causes the power unit's pump to increase pressure until it overcomes the resistance and supplies the tool with the power it needs to operate. Now, as the pressure in the hose lines increases, it causes the hoses to expand because hydraulic hoses expand and contract. They aren't made of steel, so as pressure builds, those hoses expand, which also takes time. And the real question here is, how much time will this all take? Which is where our original question comes in, that is, why would any hydraulic tool stall when it's cutting? The answer is two-ply. It has to do with hydraulics and the length of the hose the operator is using. If you're using 20-foot hoses, you'll build to operating power in about 4 seconds. But if you're using 100 feet of hose on the same power unit, it takes about 13 seconds to reach the same pump pressure. So say an operator mistakenly returns the control valve to neutral after 10 seconds because the tool doesn't seem to be working. With the control valve disengaged, the pump sees no resistance in the line and reduces pressure to the no-load condition that's used to circulate the oil, which is about 300 to 800 psi. Then the operator has to wait for the pressure to build to its full charge again. In this case, another full 13 seconds before the tool will operate properly. So what does an operator do? If you're ever wondering if the pressure is still building in the line, keep that control wide open and look at your hydraulic hoses. If the hoses are moving, that means the system is still building pressure, so be patient and keep the control wide open. When the line is fully charged, the tool will start cutting. In the next video, we're going to take a look at hot swapping and why understanding the hydraulics of a pressurized line can make your job a whole lot easier.